So welcome everybody. So we're going to be talking about how to get going on milestone 2 today. Let's see. Okay, how many people have read the milestone 2 handout already? Nobody? Okay, well, sort of. Okay, so we got at least one person who kind of tried to read it. So it's full of good tips. Read it. It'll make me happy. Send me a note on Piazza saying I read it. It was great. So even if you don't really think that, it'll make me happy anyway. Okay, so what should you do? Download the milestone 2 handout. There's a walkthrough in section 4. In particular, you have to run this command, ec297 init 2. Okay, what that does is it will add some files into your Git repo, which have the graphics library and I think I have to go look at it, a little skeleton file for milestone 2 as well. But the main thing is it puts the graphics library in your repo. The reason we put the graphics library in your repo is so you can change it. So you don't have to change it, but if you want to, you can change anything you want. So rather than just giving you read-only code, we just give you the code and you can read it all. You can change it if you like. So the graphics library we give you is called EasyGL. Read the quick start guide because you can't really draw things without understanding how to use graphics. How many people have used graphics before? Have you ever written a program with graphics in it? Okay, so we don't expect you have actually. So it's actually, I think you'll find it fun. Programs with graphics are way more interesting than programs that take text, in my opinion. If you show a program that has text inputs to your family and friends, they're usually not super impressed. But if you show them one that draws a picture, they go, "Oh, that's kind of cool." So, okay, so read that quick start guide, and I'll show it to you in a minute. You're going to modify main.cpp. So for milestone 1, your TA and the auto marker were all grading your the unit tests. Okay, so all your code went in libstreetmap/source. You're still going to put most of your code in libstreetmap/source, but you're going to write a little bit in main.cpp. The reason is your TAs, this is not auto-marked, okay? We run val grind automatically on your code, so we just check for errors, but your TA is going to run your actual main program, your mapper program, and see what he or she thinks of it, okay? So you need to write a little bit of code in main.cpp to launch your program, but then after that, most of your code is still in libstreetmap/source. That's where your drawing is going to go. And the reason you write most of your code in libstreetmap/source is we still give you unit tests. The one unit test that's quite useful will run valgrind on a small map on your program. So that's going to check for memory faults. You want to make sure that's clean. It will also run, just load and let you visualize a whole bunch of maps in the unit test so you can just look at them quickly and just make sure that, hey, all of these draw correctly. Is to help you test. But your TA is going to run your main mapper program, okay? Okay, and then the main thing that you're going to write is a function called drawMap and a whole bunch of other related functions. And those you're going to write in libstreetmap. You can write them in any file names you want, but in libstreetmap/source, just like you did for milestone 1. Okay, so your main function. This isn't going to take you very long, but you have to do it. So we wrote a little milestone 2 header file, include that. It just exposes not much, I think just one function called drawMap. Your main program, well, let me ask you this. Do you know what this is? Okay, so this is the main function, and C and C++ are interesting in that you can define the main function 2 ways, with just no arguments, that's allowed, or with these arguments, that's also allowed. Do you know what these arguments are? There's an integer one called argc, and then an array of C-style strings. That's what that argv is. What is this doing? What is this for? Has anybody seen this before? Does anybody know what those are? Okay, these are command line arguments. This is how C and C++ programs can get command line arguments. So if I typed mapper Toronto at the command line, so say I wrote that, then argc would be 2, okay? And argv of 0, the first C string, would be mapper. Sorry, my writing is pretty messy here. Maybe I'll put this down on the, that'll be better. And argv of 1 would be Toronto. Okay, so you can use this to get command line arguments. Why am I showing that to you? Your program in milestone 2 has to be able to show different maps without you recompiling it. So you can't say, oh, I put load map Toronto in my code, and oh, you want to see Moscow? Okay, I'll just go recompile it, because an end user of your program can't recompile it. So we don't tell you how to do this. You can do it any way you want, but your TA has to be able to load different maps and look at them without recompiling your program. So one way you could do that is the person could type the name of the map at the command line, and in that case, you could write a little bit of code to get the name of the map using these arguments. You could also have a little text dialogue. You know, your program starts and it says enter the map name. That's fine. You could do that. You could have a button in your UI that says, you know, enter the map name and maybe change the map. All of those are fine. Just don't make the person recompile it. So if you're not going to use command, you don't have to use command line arguments. If you're not going to use them, you can just ignore these. If you feel like using some command line arguments, that's how you do it. So your program should basically follow this convention. Load a map, just using your load map function, called draw map, which does brings up the graphics, does visualization, and then calls close map. The reason to follow that convention is then you can use our unit tests, which again are not the main thing the TA is going to run, but they'll help you check a bunch of different maps, and we are going to check you on Valgrind. So follow this convention. Okay, so obviously the vast majority of what you're doing then is in this draw map. Okay, you already wrote load map, you already wrote close map, and the code in main is pretty small. So for agile development, we always want to kind of try to get little things working quickly and build on them. So the first thing we want to do is just create an empty window. Okay, so we want to get this up. Graphics libraries usually require a reasonable amount of code to just make a window. EasyGL we wrote so that it's not that much. Most graphics libraries, there could be 100 lines of code just to get your first window going. So we want to get this going. And in EasyGL, the library we wrote for you, these buttons will be automatically created. This name at the top will be automatically created, although you should change it. And I'll show you how to do that in the next tutorial, because this is not a great name for your program. And this area, the bulk of the window, you can draw on. Okay, so that's where you're going to draw your visualization of the city. But we're not going to do that yet. We just want to get this window going. Okay, so how do we do that? So we're going to write this in libstreetmap/source. Oops. Okay, so we should put it, whoops. I'm writing this really badly. Let's try writing that more neatly. So I should write it in that directory. I can write it in any file I want. I can write it in 20 files, doesn't matter, but put it in this directory or subdirectory under it so that it goes in your library, not your main kind of launcher. Okay, so include m2.h. That defines the function signature of this draw map function that you're writing down here. And we're going to need to include a couple of header files from the graphics library so we can actually do things. So we need to include, they're all in a subdirectory called EasyGL under libstreetmap/source. We're going to include application, and we're going to include graphics. And HPP is just another word, another name for .h. Some people use .h, some people use .hpp for like, I'm a header file for C++. So that's the same as .h. So these are the two most important include files from EasyGL, and they're going to let us call its functions. Okay, so what do I do in this draw map? Let's go through line by line. So this first line says in the EasyGL namespace. So to keep the library clean, we put everything, all the classes, all the type names, all the function names in a namespace, just like STD is the standard library namespace. There's an EasyGL namespace. So this says, look in the EasyGL namespace. Inside there, there's a class called application. And in that class, there's a type called settings. I want to make an object of that type. Okay, so that's what I did. And now I want to set a few of its member variables. So settings has a member variable called main UI resource. So a resource is a data file. It's not source code, it's data. And we've made a data file. You can basically store any resource files you want. So you can make your own too. If you have data files like images and so on, you'd like to have in your graphics. We put them under libstreetmap/resources. And there's a file there that we've already once you run EC297 init2, you'll already have it called main.ui. This is an XML format file that defines the layout of the windows. Okay, you can change it. It's editable. It's put in your Git project. But we've already created a layout of the windows for you that you can use. So you should just use this. And then in the settings object, I'm also going to set something called window identifier. I'm going to call it main window. This in that main.ui, if you actually look at it, you'll see that the name of the kind of most important window that represents the whole application is called main window. So we're just telling EasyGL a little bit about where are things. And the area where you draw your map is called main canvas. And that's also defined in this main.ui. So you can just use all of these 4 lines exactly as I've shown you. We've made a layout of the windows. You're saying use that layout. And I need to tell you the name of the top level window, and I need to tell you the name of where I'm going to do most of my drawing. These are the names. And then we basically create, in the EasyGL namespace, there's a class called application. We want to make an object. We're also going to call it application. And its constructor takes 1 argument, which is a settings object. So we're going to pass it the settings object we just created. And that's it. That's enough to get the graphics state ready. And then there's one more function call. On that EasyGL application, there's a member function called run. We're going to call it. That's what actually starts the graphics window and makes it interact with you. You know, if you click the mouse, you resize the window, click a button, it takes appropriate action. It takes 4 arguments. So it can be given 4 arguments, but it will accept null for any of them. So we're going to pass null saying we don't need those yet. So I'll talk about them in lecture, but we don't need to use any of these yet. They're to make other features work. Okay. These header files are the detailed documentation of EasyGL. So you go read them to see what can I do. They're heavily commented. Okay, and I basically already told you all of this. Okay. And this application.run is not going to return for a long time. It basically takes control and it interacts with the user. You click buttons, you resize the window, it takes care of everything. Only when you click a button in it called proceed does it return from this function and kind of keep going. So this is an unusual function call in that it might be running for 10 minutes, half an hour, whatever. It can be going for a long time. So if we do this, we get this window. And we can interact with it. So let me go and do a quick demo to show you that. Okay, so let's go to drawmap.cpp. Well, actually, before I do that even, I'm going to do a couple of things. So let me pause this for a second. And go back and okay, so I'm on Quarkus right now. All right, let's see. Now I'm on Quarkus. Okay, so I told you that there's an EasyGL quick start guide. Let me just show it to you quickly. So you should go read this because it's hard to do things without reading documentation. You don't have to read that much though. It's pretty easy to read. So this gives an overview of how does EasyGL work. And I'm not going to go through all of it right now. There is an example program that you can run. It's a good idea to download that example program off Quarkus, run it, look at its code. It'll help you see how to use the graphics package. This is kind of the most important header file. So I'm not going to go through all of that. And this is the example program that I just talked about. So I'll show it a bit in lecture, but it just demonstrates how you can draw all sorts of things. So it's kind of a form of documentation. And what do all the buttons do? And essentially like an overview of the key subroutines. Okay, that's it. That's all done in the first 7 pages. So this looks, maybe it looks a bit long because it's 15 pages, but you only really need to read the first 7 pages. After that, it's advanced features. So advanced features are, okay, you made this user interface. It's kind of easy to use, but I want to change some stuff. Okay, so maybe I want to change the layout of the windows. I want to get rid of some of these pre-built buttons. I want to move stuff around. This is how do you do that? I want to add additional, what are called UI widgets, like things I can click on and do clever things with. So the next 8 pages are basically like, I'm not happy with the basic EasyGL, I want to modify it. So you don't have to read that if you don't want to. And do not try that until you've got kind of things in a good state and you feel happy and your other courses are going well. Okay, you do not have to do that. Probably 60% of students won't do that. You know, they'll just go, looks fine to me, I'm using it. Okay, so that's all on Quarkus. Go read that. The detailed documentation, as I said, is in the comments. Whoops, what's going on here? All right, let's go back to the EasyGL quick start. Okay, so I just showed you the guide. There's an example program. You should download that and run it. Okay, the detailed documentation is in the comments, and you can read that in a couple different ways. You can actually just go read the comments because you have the source files. We wrote those comments in a special way so that they can be automatically turned into a web page by a tool called Doxygen. So you can also go read the comments in the EasyGL by just going to this web page. So that's why it's linked on Quarkus. For example, if I want to look at, there's an important class called renderer. Renderer is what actually does the drawing. So if I click on renderer, I can see I have to include graphics.hpp to use it. And here are all the functions it has. There's basically, for example, let's see, let me give you an exact one, like set color, okay? So if I want to change the color, here's the ways I can do it. I can basically pass in a bunch of 8-bit numbers that are red, green, blue, and if I want to, I can pass in transparency as well. And that's not the only way I can call set color. I can also pass it certain predefined names. So I'm not going to go through all this, but basically, this is how you, if you're curious, what can I do? That's one of the ways you can explore it. Go to this web page and click on the various function links. Okay, so let me go down to, this is my draw map function just calls a helper called draw map2. That's what I'm in. Okay, so well, my draw map function does the setup code that I just showed you. Maybe I'll show it to you. Let's see. This is actually it right here. Let's see. Actually, I won't show it to you because it'll take too long. Okay, just take my word for it. The draw map function does the setup that I just showed you, and then it calls this draw map2 helper, which in turn is calling this helper. Your draw map function can get really long, and your screen redraw functions could get really long in particular. So make heavy use of helper functions so that your style is good. Okay, so here's my draw map minimal. And this is actually where I do all those settings that I just talked about. So I create the application and I run it. And let's make that run. So I'm just going to building the usual release build. Okay, and then I'm going to run it. Okay, and I have successfully opened a window. It's not super exciting. It has all these buttons pre-built, but there's no graphics that I've drawn. And I can kind of move this around and whatever. I can hit X or I can hit proceed to get out of this. So I'll just hit proceed and I go back. Okay, so let's go. Okay, so we've hit our first target though. We actually have a graphics window alive, so that's good. Now I want to draw on it. So to draw on it, I need to do a little more setup. So in my draw map function, and here I'm showing you a helper function called draw map blank canvas, but this is basically called by draw map. I have everything I had before, you know, all this setup, do the application.run, but I've added a little bit more. So in the EasyGL namespace, there's a class called rectangle. I want to get an object of that type, and I'm calling it initial world. I'm calling it initial world because world is standard graphics notation for a coordinate system. So this is about setting up my coordinate system. I'm creating a rectangle whose lower left corner is 0, 0. So x equals 0, y equals 0, and upper right corner is 1,000, 1,000. X equals 1,000, y equals 1,000. So this constructor is basically creating 2 points, one at 0, 0, one at 1,000, 1,000, and using those to initialize the rectangle. And then I basically make another call, member function of my application called add canvas. I pass it the name of the sub window where I'm going to do most of my drawing, where you're visualizing the map. And in this UI layout that we gave you, that's called main canvas. So I'm just going to use that name. I don't feel like changing main.ui. I pass in the coordinate system I want to use. So I pass this rectangle in. And I pass one more thing, and I pass in the name of a function called draw main canvas. So that name could be anything, but I'm going to call it draw main canvas. So this is important, what coordinate system I used, so it connects back to here. And this is important. That draw main canvas is what's called a callback function. So who's heard of a callback function? Anybody heard of that? You've heard of a callback function? What is a callback function? And you have to say it loud. Do you remember or not remember? Yeah, kind of like that. So by mailboxes, you think you mean like kind of events, right? Like there are different terms for these things. So yeah, so a callback function, so far the programs that you've written at U of T, you've always been in control. You write code, and when you need something done, you either write a function to do it or you call a library function that does it. But you're always in control. As you get into more complicated programs, sometimes someone else has written the control code already, and you'd like to just hand it over to them. Okay, so sometimes it's called a framework. So EasyGL actually knows how to respond to button clicks. It knows how to resize windows. It knows how to do a lot of stuff, but it has to be in control. So that's what we're doing when we call this application.run. We're basically handing control over to EasyGL. But there are certain things that it can't know how to do. So that graphics area that I told you you're drawing your city in, it can't possibly know what you want to draw there. So you have to give it what's called a callback function. A callback function is the name of a function that it should call when something happens. So this is the most important callback function, this one that we've basically put on add canvas. It's the name of the function that will be called whenever a redraw is necessary. Okay, EasyGL will redraw all the buttons and so on. It knows how to do that, but it doesn't know how to redraw your city map. It's going to call the function that you tell it to call, and I'm telling it to call draw main canvas. Does that make sense? So we're passing in what's called a callback function. Sometimes students ask me, well, how can you pass a function to a function? In C++ and C, the way a function is called is the program just goes to the memory address where the instructions of that subroutine are. So what actually happens here is the compiler, it basically knows where the instructions for this function are. It knows what memory address they start at, and it just passes that address to this add canvas. And add canvas, now whenever it needs to do a redraw, it just says, go execute the subroutine that is at this memory address. I don't know what that subroutine does. I don't care. I just know where it is in memory because the compiler told me where it is. So that's actually what's happening behind the scenes. You tell it the name of a function, the compiler hooks everything together with memory addresses, and now EasyGL can actually call this function whenever it wants. Does that make sense? So it's kind of a key notion. With graphics, you're getting into what's called event-driven programming, and that fundamentally tends to use a lot of callbacks, where you register, if this happens, call this function. Okay, so that draw callback is important. So I said the name of my drawing callback is draw main canvas. Now I need to write that. And I need to make it match the function signature that EasyGL expects. So EasyGL says this callback should return nothing, and it should take one input argument, which is a pointer to a renderer object. So a renderer object is something that EasyGL has created. It will pass a pointer to that, to your redraw function. The reason is you can't really do any drawing without it. So it's going to pass you an object you can use to do drawing. I can call this anything I want, but whatever I call it, I needed to record it with that previous function call. And then I can do anything I want in here. So right now I'm going to just draw a big rectangle. I'm going to draw a rectangle from x equals 0, y equals 0 to x equals 1,000, y equals 1,000. These redraw functions can get very long. So as you're writing it for milestone2, think helper functions. If you see your partner starting to just write lots of code in here, say, dude, where is your helper function? There's going to be like 1,000 long line routine, and our TA is going to kill us on style. So I'm just writing it. It's a short one for me, so I didn't write a helper function, but you should write helper functions. If we run this, and I'll run it in a second, you're going to get a view that looks like this. We're going to get this rectangle, okay? And the bottom left corner of it is a 0, 0, and the top right is a 1,000, 1,000. Why doesn't it go all the way to the edges? Okay, because we actually set our coordinate system to go from 0, 0 to 1,000, 1,000. So why doesn't it go all the way to the edges? It does go to the top, and it does go to the bottom. It doesn't go all the way to the left and right. So why do you think that is? Any ideas? Because yeah, so it's basically the aspect ratio doesn't match. Like the window that I'm drawing in is not square, and I can resize windows. I can make them all sorts of different sizes. So there's no way we could know it's square or not. It's up to the end user. So it's not square. What ECGL does is it doesn't want to distort your drawing. So it ensures that the size of 1 unit of X is the same on the screen as the size of 1 unit of Y, which means it just gives you an extra part of your coordinate system will be visible so that you're not basically stretching things. You expect this rectangle to be square, it is square. It just doesn't fill the whole window. Does that make sense? Okay. So let me quickly demo that. Okay, so this is way down at the bottom. So I'm going to get rid of my helper function that just brought up a blank window, and I'm going to use a slightly fancier one that draws a rectangle. Okay, let's navigate to this and go look at it. Okay, so this is the setup code. Just looks like exactly what I showed you. And I want to go look at the redraw function. So here's my redraw function. Let's get rid of this. This line's useless. So what I'm doing is I'm setting the color to black. So to get at any rendering, like drawing calls, I use this renderer pointer that was passed into me. That's the member functions of it are what actually do the drawing. So I say, I'm going to call this set color function. And you might go, well, wait a sec, what is that set color function doing? The IDE knows how to interpret the comments that we've written in the header file. So those comments, as I said, created that web documentation. You can also just go read the header file. And if you're in the IDE, it'll also pop up essentially help as you're typing things. So these are all of the functions that renderer has. There are a whole bunch of them. So there are drawing functions that draw outlines. There are filling functions that draw solid shapes. There are set functions that change how all drawing calls after that will behave. So for example, I can set colors in a few different ways. I can set the line width and so on. Okay, so there's kind of two main kinds of functions in here. There are set ones that change how the later drawing calls will behave, and there are drawing functions, draw and fill functions that actually draw things. And you can see that there's help popping up, which is what's coming from the header file as I go over these things. So let's say I don't know I don't know the name of what I'm trying to do, but I do know I'm trying to set something. So I'll say it probably starts with set. And now I've got a smaller list of things. And this set color, for example, I can go down here. And there are a few versions of set color. This is the one that I feel like using. It basically takes a red, green, and blue as 8-bit numbers and an optional transparency. So if I wanted to, I can make things partly transparent. But I don't want to. I just want to make it kind of basic. So, okay, so I'm going to basically say set color. We'll do that one. 0, 0, 0 is black. Okay, so I just repeated what I have below, so I'll delete that. But that's how you can, the IDE can help you a lot for a library that has a lot of function calls. So let's build that and run it. And it works. So let's make it full screen. And basically I can interact with it. So I can zoom in, zoom out, etc. And it's always drawing my rectangle. Okay, so every time I do something, like I zoom in, it calls my redraw function. So it's being called a lot. I want to keep that function fast. I don't have a mouse, but with a mouse, you can just use the scroll wheel, and you can click and drag, and that produces a lot of redraw functions, a lot of redraw function calls. Okay, so let me get out of that. Notice that in my redraw function, this is my whole redraw function. It's pretty simple. Oh, and I can also choose the line width. So here I said I want the line to be pretty thick, 10 pixels wide. My redraw function is very simple. How did that panning and zooming work? I'm gonna make let's try making this thinner just to see what it looks like. So let's go 3, and this is red, green, blue. Let's make the line red. Okay, so let's just change a couple things, run this again to show that it's not hard to change things. Okay, so I made a thinner red line now. That's pretty easy. But notice that I can actually pan and zoom and do stuff, and my redraw function doesn't change. It doesn't have to pay any attention to that. So the way this works is you're drawing in your coordinate system. Behind the scenes, EasyGL is always doing transformations to pixels. And as you pan and zoom, it's changing those transformations. So you can always draw the same thing, and the panning and zooming will just automatically work. Does that make sense? So it's one of the reasons we let you choose your coordinate system, and it's convenient. And by constantly changing the transforms, we can actually make panning and zooming work automatically. So it's a nice way to make a graphics API that's easier to use. Okay, so let me go on to the next part. Okay, so I want to actually draw more than that. I want to draw some intersections. So I can start drawing something that looks like Toronto. So I'm going to preload some data. Probably it'd be better for me to preload this in load map, but just to fit it on the screen, I've preloaded it in my draw map, which will also work. I've made a structure called intersection data that just has the latitude and longitude of an intersection and its name. And I made a global variable with one of those structures for every intersection. I'll show you the code for this. So the code for this basically just goes through all of the intersections. So for loop over them. And we can call streets database. It can tell us what is the position of an intersection in lat long and what is its name. And I just store that in my vector. Maybe I don't even need this vector. This is so easy to get from streets database that you could say, I don't even need that vector. I'll just call streets database when I want it. And that would be fine too. But I chose to store it in my own data here. Okay. And as I said, I'm loading it at the start of load map, probably, or draw map. Probably even better to store it to load this in load map, but either one will work. Okay. Because my draw map only gets run very infrequently as well. It's my screen redrawing function that gets called a lot, not my setup function. Okay, so now I'm into the screen redrawing function. So I just showed you I added a little bit of code to my setup code to get the window up and store some data. Now I need to actually draw this on the screen, and this one's going to be called a lot because that's my redraw function. Every time the screen needs to be redrawn, it's going to be called. So I passed in this renderer. I'm going to call it G. I already drew this rectangle. We'll keep drawing this big rectangle. How am I going to draw all these things? Like, what's the basic structure here? So you probably don't know all the details, but what's going to be the basic idea of drawing all these intersections? Am I going to need some if statements, need some for loops, need while loops? What are you going to do? So what do you think? Anybody have any idea? So I want to draw every intersection in Toronto. Do I need a for loop? So yeah, I'm going to use a for loop. I'm going to go through them all. I actually stored their latitude and longitude position. So I'm just going to use that to decide how to draw them on the screen. And there's a function. Okay, so here's my basic function. I'm just looping through all of the intersections. For every one of them, I've already stored their longitude and their latitude. It wasn't very hard to get. I just got it from Streets database. I stored it up here, okay, in these intersections. So I'll say the x is equal to the longitude, the y is equal to the latitude. I'm going to draw them each as a little square, and there's a function called fill rectangle that'll draw a solid rectangle, so I'm going to call it. And I need to decide how big to make them. So I've decided kind of arbitrarily, I'm going to make them 10 units wide and 10 units high. So I call, from my renderer, I can call this fill rectangle function. It takes 2 points. Okay, so this constructor is basically saying make a point out of the XY location of this intersection. It's lat and long. And then make another point out of its x plus 10 and its y plus 10. Okay, so make me a box 10 units by 10 units with the lower left corner at the latitude and longitude of this intersection. And repeat that like 150,000 times. Do that for every single intersection. Okay, so everybody understand how this code works? You're going to write a lot of code like this in milestone2, where you say, okay, I want to draw all the streets. Let's go through all the streets. Okay, so if I do that, this is what I get. So I still get my rectangle, but does this look like Toronto? This is not a really useful map, okay? This is like worse than even the first version of Apple Maps, right? This is really bad. So what happened to my intersections? I do have this loop. It actually did go through 150,000 intersections, try to draw them. Where did they go? Any ideas? They're actually there. So if you look carefully, you can see Toronto. So where is Toronto on this screen? It's look really carefully. Yeah, this is Toronto in the lower left corner. So that's my map of Toronto. Okay, so pretty bad marks for aesthetics and usability, right? Hard to argue that that's a good representation of Toronto. Why do I just have this little dot over in the lower left corner? So what happened? Why do I have this? Any ideas? Yeah. It's basically drawing on a few pixels. And the reason is my coordinate systems don't match. I actually said I want a coordinate system that goes from 0, 0 to 1,000, 1,000. What's the latitude of Toronto? Approximately. Okay, don't worry. It's about 43 degrees north. What's the latitude of like the northern boundary of Toronto, like Newmarket? It's like maybe 43 and a half. Okay, so our latitudes and they're big. The distance between a line of latitude is, I think, 112 kilometers. So these are all these rectangles are basically on top of each other because latitude and longitude don't change very much within a city. But I sort of inexplicably chose a coordinate system from 0, 0 to 1,000, 1,000. It doesn't work. Okay, so there are two ways I could fix this, one of which is nice and one of which is a mess. So what do you think you should do to fix this? Okay, so the way that you could fix this is a mess is you go, okay, my screen goes from 0, 0 to 1,000, 1,000. So I'm going to go back in this code and I'm going to write a bunch of scaling here to say, let's scale this so that it goes from 0, 0 to 1,000, 1,000. I'm going to work out some math, try some this, and then probably I'll wind up writing that scaling all over my program in many different places. You know, my teammate who does it for streets is going to do it and so on. I could do that, but that's not a good idea. The reason it's not a good idea is why did I choose this coordinate system of 0, 0 to 1,000, 1,000? Why didn't I just choose a more natural coordinate system? I should have chosen a coordinate system. If I want to draw in latitude and longitude, I should have chosen a coordinate system that matched latitude and longitude. The graphics API gives that to me. So should I just say, fine, coordinate system goes from y equals 43 to y equals 44? Because that'll be reasonably good for Toronto. Should I just say that? You're shaking your head. Why do you say no? Seems so enticing. Yeah, so basically every other city is going to be wrong. Okay, so for Toronto, you could say, sure, the coordinate system is 43 to 44 for the y dimension, but as soon as somebody tries Iceland or Moscow or Beijing, this is not going to work. So you have to make it data driven. So here, let me go and demonstrate that to convince you that it's what I just told you is all correct. Yeah, so basically, it's best to just set the proper coordinate system, but I don't want to do that by just setting some constants. I need to write code to figure out what a good coordinate system is for any given city. Does that make sense? So let me go and hopefully convince you that this is doing what I just said. Okay, so let me build this. Run it. Whoops, build isn't done yet. Okay. All right, so yeah, there's my Toronto. I can go zoom way in on it, but it still never looks like Toronto. Okay, so not great. Yeah, so it's like we just talked about. Our coordinate system doesn't match what we're drawing. We don't want to hard code this, so we want to go through the map data and figure out what coordinate system should we set. And we can do that. So we're trying to draw intersections. We can just go through all the intersections in the city that's been loaded and figure out what's the max and the min. And we'll use that for our coordinate system. So this is a pretty standard little bit of code. You know, if I want to find the maximum latitude of across these 150,000 intersections, because I'll just show you while you do it, you can initialize the maximum latitude, the minimum latitude, and so on to just the values for the first intersection. And then I can go through all the other intersections and I can just update. For example, the max latitude is just the maximum of the latitude of that intersection and the maximum latitude I have now. Okay, so pretty simple code. I can go through and I can find the maximum latitude and the maximum longitude and so on for the whole city. What's the computational complexity of this? So big O, is this like O1, O log n, O n squared? What do you think? It's not a trick question. So if you kind of look at it and go, it's too easy, no, it's not that hard to figure out. So what do you think the complexity of this is? I'm sorry? Yeah, so it's O n, because we just went through all the intersections. So you wouldn't want to do this in your screen redrawing function. That's going to get called a lot. But doing this in load map is no big deal at all. Okay, like that ON computations in load map, you'll never notice. So just do it in ON. There is no API call in Streets database to give you the min and max latitude and so on, but it's really easy for you to figure out. Put it in your load map. Okay, and now we use those values to set our coordinate system. So we don't set it to this strange 0, 0 to 1,000, 1,000. We set it to these values that we've just computed. And if we do that, this is what we'll get. So I'm not going to demo it, but I would get just a black spot. Why do you think that we just get this black spot? This is why you do things a little bit at a time, like always, but with graphics is particularly useful because there's a little mistake that we've made that if you've only changed one thing, you can kind of find right away. But if you change 20 things, it could take you a long time to figure out. So what do you think? Why did I get everything black? How big am I drawing the intersections? Do you remember the code? So if we go back here, I'm drawing them to be 10 units wide and 10 units high. How big is that? Okay, so when my coordinate system was 0, 0 to 1,000, 1,000, that seemed kind of reasonable. It's like 1% of the screen. Now my coordinate system is latitude and longitude. This is 10 degrees of latitude. That's over 1,000 kilometers, okay? One intersection I am drawing bigger than all of Toronto. And then I draw 150,000 of them. So yeah, I get a black screen. So it doesn't work. So I played around with the sizes of these width and height, and about 1,000th of a degree of latitude or longitude was right. That's a more reasonable choice. And as I zoom in and out, the intersections will get bigger because EasyGL is just going to transform them all to the screen. And that's probably fine. I personally think that's a reasonable aesthetic. If you didn't like that, there are calls in EasyGL to figure out how zoomed in I am. So you could change the size of intersections you're drawing based on the zoom level if you'd like that look better. But I personally just go for the easy one. It'll automatically make the intersections bigger as you zoom in, and that doesn't seem unreasonable. this is what I would get when I draw that. So it's actually starting to look like Toronto. And let me just bring up a window to demonstrate that. Okay, so let me get rid of that helper function. Okay, so now it's starting to look a bit like Toronto, and I can actually, still interact with it. So I zoom in. As I said, my intersections will get bigger, and that seems okay to me personally. But if you didn't like that, you can write more complicated code to make that stop. Okay, does this? I mean, it looks a lot more like Toronto. Is it correct or not? So it's definitely much better. But if you took this and looked at it against a map of Toronto, does it look right? It might be subtle. This is not quite right. Okay? And your TAs are going to check for this. It's right on the marking rubric. So they will catch this. This is actually distorted. And the distortion will get more extreme as you get closer to the poles. So if you check on Iceland, you're going to see it's more distorted. Moscow. The closer you get to the pole, the more distorted it'll get. So why is this distorted? So take my word for it, it's distorted. I give you a hint of what the distortion is coming from. Yeah, so we're just directly drawing latitude and longitude, but latitude and longitude are only the same distance apart at the equator. As you get to the poles, longitudes actually become 0 distance apart, whereas latitude is always about 112, I think it is 112 kilometers. I have to go look it up, but it's always the same. So this isn't right. It's distorted, and the closer you get to the poles, the more distorted it is. So this Toronto is too wide and not tall enough. And it's bizarre. You can't argue this is a reasonable choice, because a person measuring distances on the map, like how far am I walking, would always get that they can walk surprisingly fast east-west, but not so fast north-south. It doesn't really make sense. Okay, so it's wrong. And I think you just gave me the solution too. We shouldn't be drawing lat long. We should be drawing what's called the projection. This is how all maps are actually done. You have to do a projection to a flat piece of paper. There are multiple projections for a local area of the world, like a city. The world's pretty flat, and we gave you a projection in milestone 1. Okay, so you're going to wind up doing this projection all over the place. Do not embed, basically make helper functions right away. You do not want to see the same code like 50 times in your project, because you'll lose style marks, and it's also a source of bugs, right? You got one wrong and that thing doesn't draw properly. So we could make helper functions like this: x from longitude, y from latitude. Could also make a helper function that basically takes in a lat long and produces an xy from it. Xy equals some func of lat long. So maybe I kind of like to do them both at the same time. It's fine. Do either of those things, doesn't matter. But make helper functions right away. You will need these ones a lot. You might also find the opposite one useful sometimes, but they're not nearly as important. So going from your xy back to your lat long. And if you find you need those, make helper functions again. Okay, so I don't have to change my code much. Instead of directly drawing latitude and longitude, I'm just going to use these helper functions to convert into proper x and y. My x and y are now in meters, which also makes it a lot easier for me to read the size of things. So I'm now going to draw my intersections as 100 wide and 100 tall. And I know what that means. I'm actually going to draw an intersection as 100 meters by 100 meters. So it's also easier to think about. And I just draw a rectangle as before. Okay. This is my redraw function. Do I have to change anything in my setup? This is my setup and draw map. Does anything on here have to change? What do you think? Yeah. Yeah, so this initial world is wrong. So make sure that the coordinate system you ask for and your drawing calls match. You can choose any coordinate system you want, but be consistent. Common source of bugs again. So these helper functions are already coming in quite handy. I just use my helper functions and I convert these max and min lats into max and min x's and y's. Set my coordinate system to that. And if I do that, I'll get this map that now looks kind of taller and not quite as wide. And that's actually the right projection. And if you put them side by side, you can see the difference. Every year, so I'm telling you guys this, but there were people who didn't go to the tutorial who will get the wrong projection. It's right on the rubric. You can look for circular features if you want to check. So Spadina circle is a good one. Moscow has ring roads that are circular. If you get ellipses, it's wrong, okay? So let me do my last demo here. Okay, run that. Okay, and this kind of looks like Toronto now. And I can zoom in, zoom out, pan, etc., and fit it to the grid or fit it to the whole window. And I did all that panning and so on. I didn't have to write any code for, so that seems pretty nice. You don't have to draw intersections. So we drew intersections because they're relatively simple and you get the shape of the city. If you read the milestone2 handout, you'll see that it tells you you have to draw buildings and parks, like basically features, and you have to draw streets. You have to be able to highlight an intersection. Somebody clicks on it, but it's your choice. Do you want to draw intersections normally or not? And you may choose not to draw them because they might look kind of ugly on your map, right? People want to see streets. Intersections is a little bit more of an abstract concept, so you can decide whether you want to draw that or not. Or you can have a button to turn it on and off. So just because I showed you intersections doesn't mean you have to go draw intersections. You just have to draw the things the handout asks for, which are streets and features. And that's it for the tutorial. So any questions? I'll give you one piece of advice. Milestone2 usually is actually, a lot of teams have a lot of fun with it because you can create something that actually looks, graphics are just fun. Like I like graphics and that's why I like writing graphics libraries and so on. Don't leave it to the last minute because it can be a lot of fun, but it's enough work that if you leave it to the last minute, it's pretty stressful. If you don't do that, you get the basics going, then it can be not very stressful at all because you have quite a while to do it. So yeah, don't leave it to 2 days before the due date. You have like a month to work on it. Start working on it now. Okay, thanks everybody.